Okay, so few things. What we're going to be touching on today is transferring and managing large quantities of data. So we're going to touch on the different ways to transfer data between a system like the cluster or other Unix-like systems. So that includes Linux, Mac OS 10, Solaris, and other types of systems. And also, I mean, you can work with Windows. There's clients for Windows. And so a lot of you will be using Windows for end clients, and there will be clients for Globus as well as SFTP. Um, we're also going to show you how to compress data, because sometimes you have large quantities of data and moving it takes a long time. Sometimes compression, especially if it's text data, can save you 90% of the space and thus 90% of your transfer time. But a lot of times that compression is slow, so I'm going to show you a couple of standard compression tools that will be on pretty much any system, but then special versions of those same tools that uses multi-core systems to speed up your compression linearly. I'm also going to show you how to sync data between two different locations, both on the same system and between systems, as well as how to verify once you've transferred data or that it is the same in the new location. Sometimes when you're transferring large quantities of data, it transfers, but something weird happened where you're like, I think it completed okay. And you want to make sure not that it's just the same size, but that the data on storage is actually identical on both ends. And I'll show you how to do that. And I'll actually wrap up with a couple of hints on how to save space and save transfer times. Okay, so first, on our website, under the login nodes section of the resources, I want to point out something here called the transfer host. How many people are used to the two-factor authentication? That is, when you log into our system, you have to have that keychain that you have to type in a number. And if you're using SCP or SFTP or something right now and you're talking to the Flux login host, you have to type in that number every time you want to transfer files. That's annoying. We actually have these dedicated hosts. They're Nix-Xfer for Nix users and Flux-Xfer for Flux users, and they're really set up as identical to login hosts, except that you're not actually allowed to log into them. If you try to SSH into one of these hosts, you're not going to get a prompt. It's not going to let you do anything, but they will accept connections from SCP for transferring files or other SFTP clients. And you see a list of SFTP clients down here for Windows, Mac, etc. Along with example videos. And so these transfer hosts will let you do transfers with them without using your M token. So you can SCP to flux-xfer.engine.umich.edu, and it won't ask you for your M token. So I'm actually going to go ahead and do that. So can everybody see this terminal here? Actually, let me grab this other terminal. Can everyone see this? One of the question is, can you use SCP with the Flux transfer host from outside campus? The answer is still no. You cannot use SCP with the transfer host from off campus without using the VPN. That said, I'm going to show you Globus after this, and Globus does allow off campus without a VPN. Globus does allow off campus without a VPN. So I have here on my desktop, I just have this PDF file here. And so I want to send this PDF file to Flux. So if I use normal SCP, so SCP, the file I want to send, and I want to send it to Flux login colon, say I want to put it just in my home directory. Everybody remember what the tilde is? I showed that in the basic Unix commands webinar. If you don't know what that is or how the files directory layout works, check out that first webinar we did. If I do this, it asks me for my M token, and that's annoying to type that in every time, and I can only do that every 90 seconds. So instead, if I change this Flux login to Flux Xfer, now it doesn't ask me for my M token. Oops, sorry, I forgot. See, it doesn't require an M token, so I can communicate with this machine only for transferring files. So I can only use SCP, sftp, rsync with this host, and it won't ask me for an M token. Another feature is if you're transferring large files with a login host, you may run into a couple of issues. One, we kill anything that takes more than 15 minutes of CPU time. This is meant to keep people from running intensive jobs on the login node. Well, one of the issues is if you're transferring a large file, eventually the encryption overhead uses more than 15 minutes of CPU time, and your transfer gets killed off. You'll realize this when you're transferring a large file, and it keeps getting killed off at the same point every time. The transfer nodes on your hand, they have no time limit, so you can use them as much as you need. The other thing is the transfer hosts have a network connection to the outside world that is 10 times larger than the login host, so it can move data at up to 1 gigabyte per second. Assuming everything in between is good and normal SCP and SFTP, you're not going to get that sort of speed. It's pretty much impossible because of the encryption overhead that's used. But it can consume a lot more data at a much higher rate than a login node ever could. Also, because regular users can't log into them, it tends to be more stable. Login nodes get crashed every now and then for people running codes that run it out of memory or running other things on it that causes issues. Because the transfer host is only for transferring files, it's very stable, it's very solid in what it's capable of doing. So using flux-x for .engine.umich.edu for all your file transfer needs will make your life a lot easier. No more M token, faster connection, more stable. So I'll refer you back to the transfer host page where we have example videos of how to use SCP, WinSCP, and PuTTY on Windows, CyberDuck, which exists for OS 10 and Windows, and FileZilla for Windows and OS 10. These videos are a little bit older. They're going to use the transfer host FluxX but they're going to ask for an M token. That's actually no longer required. You can skip all those parts because we don't require M tokens on transfer hosts. We only require M tokens when you can actually log in and run a command, and that's a security thing. Without an M token, you can put data on the system if someone's stolen your password, but they can't actually log in and run it. So, you know, it's a trade-off we have here. We've made it easier to use, but we've limited what you can do with it. So you can use the transfer host for moving lots of data. If you're really moving large quantities of data, or you're moving large like data is going to take a long time to transfer, you might want to use something called Globus or Gridftp. There's a whole webinar just on Globus and a lot of the features it has. But this also runs on the transfer host. Globus is one of the ways you'll get much higher speeds. I'm actually running it on my laptop here. And you actually do everything through a graphical interface online. So if you go to globusonline.org and you sign up for an account, I've already logged in here, so I'm already good to go. You sign up for an account, and you just go transfer data, and you enter an endpoint name. There's several endpoints for UMich, so if I type UMich pound, I can type in flux, and oh, something's not right with it right now. Okay, here, let me use, I'm gonna have to fix that. Let me use UMich nix right now instead. So it's UMich pound the machine name you want to connect to, and you can get a visible list here of all the different ones. You'll also see that I have a couple of my own. This one right here is actually my laptop. So if I click this, this is actually my laptop over here. For those of you who use Exceed, there's Exceed on here for pretty much anything. So if I want to move data to Gordon, here's the Gordon file system. I currently have tokens for both systems. If I didn't have a token right now for, say, Nix or Flux, when I first typed in UMich pound Nix and hit enter, it would have prompted me for username and password. That's your Flux username and password. The same thing you use for Wolverine Access. If I didn't have an Exceed one, it would take me to an Exceed website where I would log into Exceed's portal, and then that would let me move data. But what this lets me do is it actually lets me just select files, click over, and it actually queues it as a job. At this point, I can log out and go home. This transfer, the Gordon machine, is talking directly to the Nix transfer machine. I've seen data move at up to about a half a gigabyte per second or more. It will also email you when it's done transferring. It also checksums the data to make sure the data that it's transferred is actually valid. And it keeps a log, so you can actually see this view transfer, and you can see all these different transfers I've done. Sometimes I've moved more than one file, and so it will actually move stuff for you. It actually does a lot of other neat things like retry. If we reboot our transfer host, your transfer won't just die. It will actually keep trying for up to 24 hours for our host to come back up or the network in between to be fixed. There's also a few other pieces of things you can do here. Note, by default, data are not encrypted. Your authentication is, but your data are not. Most of you don't need encrypted data, but sometimes you do. If you want to encrypt your data, check that box. Also, notice there's some syncing functionality. Only transfer new or changed files, and you can give a version here. So you can actually use Globus to sync between two machines. You've updated some data in like some global repository. You can say transfer only new or changed files. Some of these take longer than others because they're more abusive, like calculating checksums, of course, takes more time than just how big are the files and are they different sizes. If they're different sizes, transfer over, and if it doesn't exist, of course, transfer it over. So you can use it to sync. You can also say delete ones that don't exist on the other side. So you can use Globus to do a lot of things, but it's really nice how it's hands-off. You start to transfer between the machines, and you can just log out and walk away. I can use this to transfer between two different Exceed machines. Again, these machines are ridiculously fast because they're dedicated transfer machines. In the back end, it's using something called Gridftp to actually do the transfer, which is for heavily used by the high-energy physics community. Like if you've heard of the Large Hadron Collider and the petabytes and petabytes of data, the way they distribute that is actually using the same technology. You can get Globus running on your own machine. This Get Globus Connect, you can get it running on, here's what I did to be able to get it running on my laptop. So I was able to type in BrockP, which is my username, #MacFoo, which is my laptop I'm on right now. You can also get it for Linux and for Windows, and you can get it running on all those different machines and transfer data between them. In the future, they're actually enabling the ability to share data between machines. So you can actually give different users access to data on your machine. So I'm going to direct you to the webinar that covered a lot more details on this, which you can find in the webinar archive, where it went through a lot more details about how that works. Can you use Globus to transfer files to your local computer? Yes, you can. That's that Get Globus Connect. And basically you install that, which is a very simple version of a Gridftp client, and you don't even have to worry about firewall rules or anything like that. Again, I'll point out that you can use Globus to transfer files from our systems from off campus without the VPN or any tunnels. That is the only way, without jumping through any hoops, that we let you transfer data to and from Flux or Nix from off campus without using a VPN. So it's faster than SCP. It's more reliable than SCP. We let you use it without an M token. We let you use it without needing a VPN, and we let you use it from off campus. It's probably the best way for moving data between our local machines and Exceed resources. And there's other resources on there too, things like NERSC and DOE and a few others. It's just generally, I pretty much use it for all my file transfers now. I pretty much use GlobusOnline for all my file transfers. And you don't need to leave your terminal open to keep it running. And you can script it if you want. There is a command line interface besides the web page. Okay, so that's the transfer hosts. So you can use them to be able to move data back and forth. They're faster, and you can interact with them using SCP, sftp. And again, I'll direct you to our login host webpage for details on how to use those. And GlobusOnline to transfer data. I want to point out a few things about our system. So if you're on Flux, you may notice a couple of different file systems. When you first log in, you're in what's called your home directory. It's either going to be home or home2. Can you use Globus to move data from another host? You mean another site? Okay. They have to have Globus running themselves. That is, they need a Gridftp server on their end. But then yes, you can. If they have a Gridftp server or a Globus endpoint, you can use it. Even if it's not currently in the GlobusOnline database of hosts, you can use it if they already have a server running. I can show you how to add that. That's outside the scope of what we're covering here. But if they say, yes, we have a Gridftp host, come back and talk to me. Okay, so file systems on the machine. When you first log in, you're in a home directory, which is either home or home2 / your username. Few things about this. This is generally not where you want to run applications from. You have at least 40 gigabytes of space here in terms of quota, but it's NFS, otherwise known as Network File System. NFS is very reliable. It serves us very well, but it doesn't have the best performance characteristics. Also, it only lets you have 40 gigs of space. Also, no file systems on our system are backed up. None of them. You'll notice one of our file systems is actually called no backup. Tried to make that a little bit clearer. But we do get asked that every now and then when people delete files. If you delete a file from no backup or from scratch, there's no way of getting it back. Deleting a file from home or home2, if you let us know right away, sometimes there's a snapshot, but that's not an advertised feature of something to rely on. So don't, and again, snapshots are not a replacement for equipment failure. So if there's equipment failure that causes us to have to reload the whole thing, your data are gone. So it's up to your own responsibility, which is why we're talking about this. We're talking about how to transfer data off of our machine to other places in a reliable way. So home, where you start, reliable, slow, small. If you're a Flux user, there's a space called Scratch, which is very large. It's currently over 500 terabytes. It's also very fast. You can get data onto it at over 5 gigabytes a second when everything's running perfectly. In practice, a single host never gets faster than 1 gigabyte per second, but that's still writing 1 DVD every 5 seconds. So it's really fast. It's also very big, and there's no quotas. If you have a Flux allocation, you have a Scratch location. So Scratch, my Scratch location is support Flux, and then my username. So this is my Scratch space, and this is where I have a bunch of data. The same thing applies for engineering users who have no backup. If you have your own value storage mount or NFS server in your department that you run, say for like holding genomic data sets or something like that, talk to us, we will mount them. You'll notice here this MCFS home. This is an example of someone else's NFS server being available on a Flux host. We will actually access your data for you directly, so you don't have to transfer data back and forth. You can write directly to your own disk. But still, most of the time, you want to do your work out of Scratch, which is the big, fast, parallel file system. For a lot of details on Scratch, refer to the blog post on our website that I wrote last week. The thing is, the policy for Scratch is you only have a space there while you have an active Flux allocation. You can find this off of our webpage. If you just search for Scratch, it will list out the policies of the Scratch file system. So while your Flux project is in effect, you can use your Scratch space, but it is a Scratch space. It's meant to be a working area. You can see here, 5 days after an allocation expires, the top level directory will be unreadable. 60 days after an allocation expires, the contents will be permanently removed. So we will delete data from your Scratch space if you're not currently able to use Flux because you don't have an active allocation. So you need to be able to move data on and off quickly, and that's where the things we talked about, Globus and other things, become useful. Same thing applies to no backup. None of these file systems are meant to have long-term old data. They're not backed up. They're meant to be fast, so they're not necessarily designed to be the most reliable. They're designed to be fast and big. Okay, so Couple examples here. Let's get back into some details of how to do stuff. So we talked about SCP for transferring files, Globus. Remember how Globus had some syncing functionality? What if I just want to sync some things right here? Um, there's a command called rsync. And you can use this from your own machine, and it exists on my Mac. Rsync is for syncing files. You can sync directories. You can make things match and look the same, and it will only move the data that are changed. So if I go back to my my laptop here, I make a folder, and I make some files in it. They're empty. If I wanted to sync this folder up to Flux, I would do, without using GlobusOnline, I would use rsync. See, I have rsync on my Mac. It's built in. It comes with it. I always like to use -a. It's just what I do. I would say the folder I want to send, which is this folder, and then the host and where I want to put it. So I'm going to use flux xfer. And then just like, it's basically the SCP syntax, colon where I want it to go. So I want this to go into my home directory. Okay, so if I go back here and I go to my home directory, well, I'll find a folder with 4 empty files, A, B, C, and D. Now, here's what becomes interesting. If I go back in the folder and say I add a new file called 1, and I'm going to put some data in one of those other files. I'm going to change its size and contents. Okay, so now A has some stuff in it. It's newer than the other files. So, and I've got one new file. So here's what I'm going to do. I'm going to run rsync again, the exact same thing. What rsync is going to do is, actually, I'm going to add an option here. I'm going to add -v, so you can see it'll actually print out what it's doing. Notice it moved only A and 1. 1 was new, A changed, so it moved only those 2 files instead of everything in that folder. So you can use this rsync command to sync folders. One thing, there's a delete option, which I didn't specify. That is, if I deleted a file locally, it will also delete it remotely. So the sync by default is basically push new and changed files, but don't delete things at the destination that I don't have locally. But you can enable that to literally sync between the two. And you can go in the other direction. So just like you can, so think of it as you can pretty much drop in the command rsync for replacement for SCP. If you have a lot of files, though, SCP will have a lot of overhead. One question is, what does the -a do to rsync? Let's actually take a look at that. Everybody remember the man command, where you get the documentation? If I search for -a, A is actually a bundle of options, which is archive, which is basically says preserve the ownership and time of the files, and a bunch of other things. Go recursively into folders and a few other things that I just like having it all on. But you can actually look at what these options are in the manual page for rsync. You can also search for it online. It's a very common command. Like I said, pretty much all Linux and Macs come with it already built in. And of course, we have it on ours, so you can use it to sync. The overhead for rsync, though, for a lot of files can be higher. So don't use rsync if you know the entire folder doesn't exist. Use SCP instead. Or actually, even better, use Globus. It'll be faster, but you can use it. Also, you can use it to sync stuff locally. So I can do rsync folder and give it a new name, folder 1. Oops. I got it. So I don't even have to go between hosts. I can actually just sync the two together on the same machine between two different locations. So I could have like a backup location or something like that. So that's rsync. A lot of people don't know that exists, but it's super useful. If you're moving text data over a very slow connection, you can also use rsync -z with your other options. -z enables compression on the fly, zlib or ziplib. So if you're moving, especially text files, if you have a lot of text data and you're going over slow connections, so you're bandwidth bound, but you have lots of CPU, turn on the -z. It'll get you effective speed up by using more CPU, but use less network connection. So you can push more data through the existing network connection. Generally on our systems where we have fast disks and large networks, the Z overhead will actually slow you down. Can you use rsync to sync data from a remote machine to your machine? Yes, it works the same way as SCP. So when I first did it, and I did folder and it was host : path, just switch it. Do rsync host : folder I want to sync, path on that system, and then where I want it sunk locally. The location, or use dot or something like that. So yeah, you can actually switch it around. So if you're using something like FluxXfer where we don't let you actually log in directly, but you want to sync from Flux down to your local machine, that's what you would do. I would do, so actually let me do it. So here on my machine here, I'm going to do rsync FluxXfer, the folder I want to sync, which is homebrocp folder 1, and I want to dump it on my desktop where I currently am, so dot. So this is going to pull data from Flux locally. And now I have folder 1 on my desktop. Can you use rsync when you're outside of campus? Rsync is still using SSH underneath, so everything that applies to SSH applies to rsync. So without the VPN or a tunnel, no. You cannot use it from off campus without the VPN or a tunnel. You can use Globus, though, and its syncing functionality from anywhere in the world. Okay, so that's the file transfer thing. So rsync for syncing files, SCP and sftp for moving files. Again, refer to the videos on our transfer host webpage. Always use a transfer host when transferring files. It'll save you a lot of headaches. No M token, no CPU time limit, very stable because users can't log in and actually crash it. But remember, you can't actually SSH in. You can only talk to it using file transfer commands. They have 10 times faster connection to the outside world than a login host. And they run something called Globus or GlobusOnline, which is really, honestly, of everything I've showed you, the preferred way. It takes more setup, but it is faster, more reliable, and has more features. You can also use it from off campus. Okay, now I want to point out a couple other things. I want to show you guys compression. So there's two different types of compression. We're only going to touch on one here because the other one is not useful for scientific data normally. But there's what's called lossy compression, and that's something like digital images. We're going to throw out some data, and it's going to get a little grainy, but we can still see what it is. We're going to be talking about lossless. That is, we can compress data and get the original back. This applies mostly to textual data, but sometimes binary data will compress if it has a lot of repetitive pieces in it. So the two most common forms of compression on scientific systems are gzip and bzip. There's other ones out there like szip that has some licensing constraints. So if you're going to use szip, which I won't cover here, which can be faster and have better compression with scientific data, it has some licensing constraints, so check it before you use it. But gzip and bzip are the most common ones. Also, my Mac and my Linux box comes with it. The gzip command's there, the bzip command's there, the gunzip command is there, and the bunzip command is there. Also, a lot of the universal compression tools for Windows understand these two common formats. Gzip for text data will give you very good compression. It's also going to be pretty fast. That is, it's going to be fast at compressing and decompressing. Bzip's going to give you better compression, but use a lot more CPU, so it's going to take a lot longer. I actually use bzip most of the time because of some tools I'm going to show you. So I actually have here in my Scratch directory a set of data called ngrams. It's just text data, but the files are relatively large. If we look here, the Z file here is 130 megs, but the T file is 1.3 gig. So this is the raw data. If I look at like the first few lines of the Z data, you can see it's just text. And so I want to compress this. I want to compress the Z file so I can move it easier, because transferring 130 megs of data over, say, my home internet connection, it takes a while. So I can run gzip on it. It'll compress, and it's going to take a while. So it took a while, but it's going to create a file called z.gz. And see, now it's only 27 megabytes. So it's, you know, not 10 times smaller, but it's quite a bit smaller, and it definitely didn't take that long. So then I can transfer that back to my home system, and I can run gunzip on it, and it will decompress it and write it back out. Now, this terminal over here, what are you looking at? This is the Scratch client throughput on the machine I'm running on. Here, let me stop it for a moment. This first column is the number of bytes, kilobytes per second, that are being read, and this is the number of kilobytes per second being written in this third column. We want these numbers to be as high as possible. That is, we want to compress data as quickly as possible, so we want to be reading a lot in, and we want to write it out as quickly as possible when we're uncompressing it. So this will be able to use this as a proxy for how fast things are going. So that zip, again, you know, it takes a little while. So I have a couple of special commands that are special versions of these same utilities. If I run module load pigs, the pigs command is a parallel gzip. So what this will do is, okay, so here, let me do something. I'm going to time zipping that Z file. The time command is going to say how long a given command took to run. You can see here we're reading data about 20 megabytes a second, so it took 6 seconds to compress it. So let's uncompress it. Uncompressing takes a lot less time, but let me use pigs on it instead and time it 7/10 of a second. If you notice here on my client, I read at 106 megabytes a second. The reason is pigs is multi-threaded. I'm currently on a 12-core node on Flux, which is the smallest node on Flux. It's 12 cores. So I used all 12 cores to compress. Default gzip and bzip only use 1 core. They're not parallel. So even on your laptop where you have multiple cores, it won't use more than just one of them. And compression scales linearly. Few things about gzip though. It's faster. It doesn't compress as well as gzip or bzip. One issue though is you can't decompress it in parallel. There is a unpigs, but it's no faster than the normal gunzip because you can only decompress in 1 thread at a time. On the other hand, if I do module load pbzip, this gives me 2 different commands. pbzip, which is a parallel bzip. So here, let me unzip that Z file. Oh, one thing too. Pigs, the parallel gzip, and pbzip, the parallel bzip, they are compatible with the standard gzip and gunzip and bzip and bunzip that come on like your Mac by default. So if you compress something on our machine using our parallel bzip, transfer that to another host where you can't install bzip, which is for free, available online from compression.ca. Thank that guy in Canada for making that. But you'll be able to uncompress stuff that you compressed in parallel with the standard uncompressor. The inverse is also true, but parallel decompression doesn't work on files that were, because remember, only bzip is parallelizable decompression. Only works on files that were compressed with parallel bzip. Little caveat there. So gzip can never be parallel decompressed. Bzipped files can only be parallel decompressed if they were originally compressed with parallel bzip. But no matter what you use to compress either of those files, bzip, parallel bzip, gzip, or parallel gzip, you'll be able to decompress them with the stock decompressors, the ones that come on any Linux box and come on any Mac, and any gzip, unpacker you can install on Windows. So let's do a little bit larger file here. The A's are 1.7 gigs. So let's compress A using pigs. So this is going to go, I'm reading data off of Scratch at, I hit 200 megabytes a second there. 230, 140, it varies, but it took 10 seconds to compress that. It's going to take me a little bit to decompress it. Because remember, decompressing gzip can only happen in serial. So I'm only writing data at 40 to 80 megabytes a second. So because I can compress in parallel, but I can't decompress in parallel, I can actually compress gzip faster than I can decompress it, which is normally the inverse. So this is actually taking a while. A really long while. Okay, so it took 31 seconds to decompress it. Okay. Parallel bzip, on the other hand, bzip, it gives me better compression. So remember, it gives me better compression, but it takes a lot more CPU. So it's disproportionate. If it takes twice as long to compress, it's not necessarily going to be half the size. So see, it took 3 more seconds to compress this, so 30% longer than gzip. But the file is only 300 megabytes now instead of almost 2 gig. But I can use -D for decompress. And this will also happen in parallel. Now, I'm going to show you something after this that, so bzip takes a lot more CPU, but being able to use all the cores on your box makes it a lot faster. So I pretty much use it because I get parallel decompression. But if you need to use gzip, pigs totally works great. There is something interesting, because I'm actually in an MPI job. So I have 60 processors here in this job. I actually have a special version of ngrams here in this folder called Stripe 8, or actually no, I got it in Stripe 4, where I have the all database, which is all the files, which is 24 gigabytes in size. 24 gigabytes in size. But I've done something called striping, which on Scratch you can spread data across multiple disks. By default, when you write a file, it's written to one disk. And so if you're working with really large files, they should be striped. This is something you have to do. You have to refer to a webinar I did last year on the details of that. But basically, if you're working with large files, this will make it faster because I get to spread it across multiple things. So I have this file, this 24 gigabyte file called all, spread across 4 different sets inside Scratch. Scratch has 30 sets of disks that you could spread across, but I've got it spread on 4. There's actually an MPI version of there's an MPI version of parallel bzip. And so if I run -v, which will print out information on how fast it's going, and I actually compress this file. Watch this. This is going to be cool. I'm actually going to be limited by the disk system here. So there you saw I was reading data at 240 megabytes a second, 100 megabytes a second, 200 megabytes a second, 220, 340, 240, 300 megabytes a second, 300 megabytes a second, 230, 200 megabytes a second. So I am reading data at anywhere between a tenth to a quarter of a gigabyte per second. And so that's how fast I'm compressing it, because I'm actually using the way this works. There's one master, and then the others actually do the compression. So I'm actually using 59 processors right now to compress. So I'm actually limited by the disk right now in terms of how fast it's compressing data. The CPUs are actually waiting for data. This is the inverse of what you normally find when you're compressing large data. And so you can see, there it goes. Look at that go. So I am compressing a 27 gigabyte file ridiculously fast. So this is the MPI version. PBzip is the normal one. You would want to use this on the login node because it's just threads and it's quick and easy. But say you are running a big parallel job and it writes a big set of data at the end, you could actually include MPI run, MPI bzip, the files you want at the end of your job, and use your allocated parallel processors, all of them, to compress your data at the end of your job and take it other places. So I'm going to compress this 27 gigabyte file. You notice the speed can be a little inconsistent, but it's still very fast. I've never seen it drop below 80 megabytes a second here. And all 1,000 machines on Flux are hitting this disk right now, so who knows what's going on right now. While we wait for this to finish, are there any questions or anything like that? How well does it work to compress a directory with 31 gigabyte files? Just as well. Now, most of these compression tools, they don't take a directory. They only take individual files. So you'd either want to, run it on all of them independently. And there's actually an easy way to do that. You just say like, pbzip star, which is everything in the directory. Or you can combine it with a command called tar. And with the tar command, you can get it. Tar is basically the file bundler, and tar can compress. So actually, if you run pbzip by itself, with -h for help, it shows you how to use it with tar. So if you wanted to tar up, okay, so actually I've got this directory called stripe 8, which has A through Z in it, and it's 24 gigabytes of total data, which kind of makes sense because the all list. What I can actually do is I can run tar, create an archive. I'm going to put it in my scratch. So ngrams.tar, and the convention is to put bz2 on the end for bz files. But then I'm going to say use compress program pbzip2, and then the directory I want to compress. It was called stripe 8. And so tar on Linux systems comes with bzip support built in, but obviously that's the default serial one. It also comes with default gzip support built in, and so you can use this use compress program to give it your own custom compressor, and then it will use that. So this will actually now, it's not the MPI based one. You're not going to be able to do the MPI based one, but this will still let you use whoops. Why am I trying to write to Tony's directory? because I'm mean like that. So it unfortunately can't use the MPI based one, but I can still use the multi-threaded based one. So if I look here, if you look in this terminal here, you'll see my bzip here, and it's using 1200% CPU because it's running 12 threads. So you can use it with tar to bundle everything all at once, or you can do something like this. I just killed that. So if I go into the Stripe 8 folder, if I just wanted to bzip all these things, I'm pretty sure this will work. If I just say that, or I can, yeah, well, yeah, I'm just star means everything, ls star lists all the files. So bzip minus v star. It's just going to walk through them one by one. The -v just prints out this extra information. You wouldn't want to use that normally. And so first it's going to see file 1 of 26. So either way you want to do it, the tar is going to give you one big file at the end that has everything in it. And when you untar it, refer to information online, it'll blow up into all the individual files again. Or you can do something like this where it will compress them all into a bunch of compressed individual files rather than one archive file. So it's your choice what you want to do. You can do it either way. Two of them got compressed here. I killed it manually. You can also decompress by saying star. I'm using star.bz2 because the other ones aren't compressed. Because that's what I'm going to refer to the two. And so that will decompress both of them now. Since they were compressed in parallel, they will decompress in parallel. And so you can actually see I'm writing data at 400 megabytes a second. So a half a gig every second almost. Okay, so that's parallel bzip. So module load, pigs for parallel gzip, pbzip for parallel bzip, and MPI pbzip for the MPI based parallel bzip. Both of them just run -h for help for all the details on different options for it and different things. Okay, so say I've done all this compressing and I've moved all these files around between places, but I want to make sure that the data are the same after I've compressed them, and decompress them on another machine or transfer them someplace else. What you can do to verify that the data are exactly the same is you can calculate what's called a checksum. And one of the easiest ways to do that is by using a command called md5sum. On my Mac, it's called md5, not md5sum. But what I'm basically doing is I'm calculating the md5 cryptographic checksum of the data of a file. So if I just say md5sum a, this is now going to calculate a unique number for the data in that file. And md5sum is very fast. Remember, A is almost 2 gigabytes in size. But even though it's not parallel, it still calculated it at a half a gigabyte a second. So you don't even really need a parallel one. But this magic string here uniquely identifies A. If I modify the contents of A in any way, that will change. So if I transfer it and something happens where the data gets written wrong, if I run md5sum on it here and then run it there, and they don't match, I know the data aren't the same. So you'll see this sometimes when downloading source code that they'll give you an md5sum so that you can verify that what you downloaded is actually what they published. So you can just run md5sum, the file name, and it will calculate a checksum. So if I zip that file again, the zipped file will have its own checksum because it's different data, right? It's a compressed form of it. So I have the checksum for A. I'm going to compress it. I'm going to calculate the checksum of A compressed. Goes a lot faster because it's a lot smaller, but notice it's very, very different. The smallest changes in the file makes the checksum completely different. But now if I decompress it, because this is lossless compression, it should be identical to what it was when I started. And I run the checksum on the now decompress data, I should get the exact same thing that I started with, and I do. So that's how I know that my data has not changed. So that's just like a handy little thing. So a few things. If you're writing data, try to write it in binary. It takes up 1/3 the amount of space, so it writes faster because you're writing less data, and you can transfer it faster. It won't compress as well though. But actually, what it will work out is that the compression ratio is you're basically gonna end up in the same place, and you don't have to deal with compression. So write binary. But sometimes that's hard, or that's not where your data comes in, and things like that. So sometimes compressing stuff is nice. So you can compress data, move it where you need to over slow connections and things like that. There's another module on here called PCP. Whoops. PCP is a real fun one. I want to just point this out real fast. So I have this folder called Stripe 8. And I want to copy the whole thing. It's got a bunch of files in it. PCP is a parallel copy. And what it's going to do is it's going to take your folder, all your files in it, and it's going to copy them in chunks. So I'm going to use 12 processors spread across machines to copy the files in groups. It doesn't break up the individual files, but it does take groups of files at a time. So if you need to copy a very large folder with a bunch of things in it, this will go a lot faster and you can spread it across a bunch of machines. So I'm going to take Stripe 8 and I'm going to make it a new folder called Stripe A 8B. And so I'm copying those files at 300 megabytes a second, basically. And I'm only running this on one host with only 12 processors. But see here how it's ranked to copy this file at 60 megabytes a second? It's because I have 12 things copying simultaneously. So the individual number printed out here is what 1/12 of the system got at a time. So it's just splitting them up across all of them. That's everything I had. Again, if you have questions, send them to hpc-support@umich.edu. We will have this, again, this is recorded and we'll place it online. If you have any questions, please ask them now. Otherwise, send us, any requests for future information to cover. Hopefully you found this useful. A lot of people don't know you can compress data, and they would spend a lot of time transferring stuff back and forth. But you can use the parallel compression tools that we have installed. They're both PIGs and bzip are free. You can download them, install them on your own machine. So you can take advantage of multiple cores in your own local machine also. And again, I stuck with ones that the parallel version works with the more common serial version. So if you have data in one format, you can get in the other. You're just going to run into issues that if you're given data that's already been gzipped and they didn't use the parallel, or if it's already been bzipped and they didn't use the parallel one, the parallel decompress isn't going to help. It's going to be your own data that you compress with the parallel one that then you can parallel decompress. One question is, GlobusOnline the best way to talk to Exceed, and is there a command line interface and their documentation for that? Yes. I would say it's the best way, and there is a command line for it, and it is documented on their website. So yes, there is. There's also, if you look on our website for something, if you run module load, this web page here, check that out. That includes information for another way to transfer files to and from Exceed. Specifically, if I back out, if I run module load Exceed, and I run my proxy login, it'll ask me for my Exceed portal password, and that'll give me a token where then I can run GSI SCP, and I can transfer, just like using SCP to something like Kraken, and it won't ask me for a password. So that's another way to transfer files, just like using normal SCP, but use a special one to and from Exceed resources and our local resources, because they want you to do everything using the portal password. There's also a GSI SSH, so you don't have to use their Java portal thing. That's actually what I use. So read the documentation on that webpage. But I would say, especially for moving large quantities of stuff, GlobusOnline is definitely the preferred method, and they do have a command line way of interacting with it. But if you want to do things like what you're used to with SCP, you can use GSI SCP. Other questions? Okay, again, if you go back up to our the top, you can find our Twitter as well as our YouTube page, which has all the previous webinars and where we will post this. Again, I'm going to try to do these still every other week, so around the same time, 2 weeks from now, we'll have another topic. If you have questions or something that you think we should cover, go ahead and send that into hpc-support, and we'll be sure to touch on it. So otherwise, that's it, and thank you very much for your attention.